Hi guys. Hi. So to get back into the swing of things, we're going to be kicking it off with 8.1, which is where we left off, and that's our new module, which kind of works out good. So let me go ahead and share this with you so you can see what I am seeing. Here is that. Okay. So we're going back to triangles again, and we're going to deal with different lengths and trying to figure out how to figure out the lengths of lines. So normally the cheerleaders would line up kind of like this. Okay, so you have none are directly in front of the other, but they map it out on a grid so that they see it like that. Well, they're going to a new pattern where they have one cheerleader in the middle, and they have one cheerleader out here, and they have another cheerleader out here, and so on and so forth all the way around. Okay, we're not worried about all of these cheerleaders though, because the question is asking if they tied a ribbon, if they ran a ribbon between the center cheerleader and the outside cheerleaders, would they all be the same length ribbon? Do we just cut them all the same length? Or do we need to cut different lengths for them? So we're going to look at these two cheerleaders because they represent all the others. So from G here in the middle out to B, that's this line right here. Okay, we're going to be looking at GB, and notice I did not put a line over the top there. That's because it's a measurement, it's a length, so we don't draw the line over the top. Okay, we're going to be trying to figure out this length right here, and then we're also going to try and figure out G. Oops. So GC. Again, no line over the top because it's a length. So we're looking at GC, and we are going to be looking at, whoa, the monitor screwed up a little bit. Okay, so we're looking at GC, and we want to figure out this distance right here. Let's make this a little bit bigger so it's easier to see. Boom, there we go. Okay, sorry about that. Now we can all see it together. So we're trying to figure out this distance right here. So 1, 2, 3, 4, 5. So that distance is fairly easy to figure out. We can just count it off, right? So that is 5 units. Okay, units. Okay, whatever those units are, it doesn't matter. Feet, miles, yards, acres, whatever. There's 5 of them. Okay, and then we have GB here. So this one we got to figure out. This is a little bit harder. So this from here to here is not a single unit. It's not one unit because a unit is one here and one here. Okay, so we're looking at one here and one here. What does this look like right here? Okay, I would call that a right triangle. And what do we know about right triangles? Anybody remember? We know that a squared plus b squared equals c squared. Okay, so this would be a, b, and c. And a is one unit. A is 1 squared plus b is 1 squared equals c squared. That's what we're trying to find, is that length right there. So I have 1 and 1. So 1 plus 1 equals c squared, or 2 equals c squared. Then we take the square root of both sides. So the square root of 2 equals c squared. Okay. So how many of these units do we have right here? So we have 1, 2, 3, 4. So I have 4 of these. Oops, that doesn't equal c squared. What am I doing there? That equals c. Okay, and I have 4 of these. So times 4, So we're going to have 4 times the square root of 2. So 4 times the square root of 2. Okay, so if we pull a calculator up, we can approximate that. The calculator here. So 2 square root times 4 equals approximately, okay, 5.66. Okay, 5.66 units. So that's what we're looking at. It's 5.66 units from the center here out to B out here. And it's 5 units from the center here out to C out here. Okay. So we're going to carry that over to the next one and explain how you found the length of each ribbon. So for GB, we used the, let's see, make sure that's the right one, GB. Yeah, GB, we used the Pythagorean theorem. Pythagorean theorem. Wow, my pen's not writing very well. And to find C, and for GC, we counted the units. Okay, so when they finish the ribbons in this position, they're considering using them to form a new pattern like this. So they're going to use these ribbons here and here to move out here and here. Okay, so will the ribbons they use and the previous pattern be long enough to go between Brittany B and Courtney C? So we're looking specifically at this pattern right there. Okay, explain in the new answer, explain your answer. So here I have a triangle, right there, but is it a right triangle? That's the question. Do I have anything telling me that these are 90 degrees? So if we look back here, the reason I could do the Pythagorean theorem here is, if you remember in the rules that I gave you, where 2 grid lines meet, we know it's a 90-degree angle. Okay, we talked about that last time. So here, I don't have anything telling me for sure this is a 90-degree triangle anywhere in any of those corners. Okay, so I have to assume that this is not a 90-degree triangle. I can't just use Pythagorean theorem to find this length there. Okay, so what we're going to do is we are going to make this into a triangle that we can use, okay, here. So if I make this into a triangle I can use, so I go straight down from B, and I end up here at 3. Okay, then I have to figure out this length here. And that length is pretty obvious. So we made this into a right triangle here. Okay, so if we come back here, what we did was, let's clear all this out real quick. Okay, we dropped this line down. Oh, apparently they moved it. So we dropped this line down from here, and it looks like it's in a different spot. So that's at 5. She's at 3 there. Yeah, she's at 3 there. So here we can actually see where she's at. When we come here, you can see that Brittany is out here on 4. So we're going to go with 4 and 5 because this actually has the grid lines to follow. The other one does not. So 4 to 5 is 1 unit. Okay. So our triangle has 1 unit right there. And we need to know how many units it has right here. So we count off 1, 2, 3, 4, because that's straight over from 4 there. Let's double check on our pattern that we're using. 1, 2, 3, 4. Yep. So we're going to go here and here. So that's the height and the width of my triangle. That's my A and my B. I'm going to use this grid right here to show 90 degrees. Okay, so this triangle right here. And I need to figure out that length. So that's going to be my new A. That's my new B. And then this one's obviously C. So when we use those, come back here and do the math here, we get 1 squared plus 4 squared equals C squared. Okay, and C squared has to be what? If the ribbon is going to go from Courtney to Brittany here, it has to be at least as long as one of the ribbons from Gabrielle or whatever her name was in the center there to Courtney or to Brittany. So it has to be, so the ribbon has to be less than, what was it, 5.66 units. Okay. So here I have 1 plus 4 squared is 16 equals C squared. So I get 17 equals C squared. So I get the square root of 17 equals C, because I take the square root of both sides here. And I missed on that one. Square root of 17 on both sides. And so C approximately equals, go back to my calculator here, boom, 17 square root, 4.12 units. So can we take this ribbon here and use it to come across there? Absolutely. Yes, because, okay, this is very important. You have to explain your answer. Yes, because 4.12 is shorter than the 5.66 length of the original ribbon. Okay. So Gabriella notices the calculations she made for the length of the ribbon remind her of math class. She says to her group, hey, I wonder if there's a process that we could use what we have been doing to find the distance between any 2 points on the grid. She decides to think about it like this. Okay. So move down here and look at the way Gabriella thinks about it. So I'm going to start with 2 points and draw a line between them representing the distance. So she draws this line. Okay. Since the 2 points could be anywhere, this could be anywhere in the world, anywhere in existence, anywhere on the grid, doesn't matter. Okay. She named them A, and A has an X value and a Y value. I'm actually going to change up this color, make it a little bit easier. So A has an X value and a Y value. Okay. And B has an X value and a Y value. So we call those X1. Sorry, I call them the other way. So X1, let's do this. Let's make it a little easier. X1 and Y1. It should be written there on your paper already. Okay. So then when I need to figure out the length of the ribbon, what do I need to do next? So we think back to the process you used to find the length of the ribbon. Write down your steps here in terms of X1, Y1, X2, Y2. So let's go back here and we'll look at how did we figure this out. Okay, so let's look at the math. How did I get 1 here? How did I get this 1 right there? Okay, so when I look at where I got my calculation from, we counted 1 unit, right? So how do I figure out this 1 unit if there's no unit numbers? Okay, if I start from some 0 here in the middle, pick blue. So if I start from some 0 here in the middle, and I go out this far, okay, let's call it 4 feet. And I need to figure out how far from 4 feet I went. Okay, I'm going to take the distance from the 0 still out to the new measurement. So how do I figure out this right here? I'm going to take a difference. So the difference between this line and this line, the difference between this line right here and this line right here is going to be 1 unit. Remember, difference is subtraction. So if we think back, we took x2 and subtracted x1 from it. Okay, and that was, so come back here, that was this first number right here, and that was squared. Okay, so we need to square all of that. That's our a term. So squared plus, then we take our y values here. So let's say it's from some 0 right here, and we go up that many to get to the y there. Okay, and then we go up to where our by is going to be over here. Okay, so we go up this many to get to where our by is. So the difference again here is going to be 1, 2, 3, 4. So from 0, I'm going to take away my b, or sorry, not my b, my y right here, my y2, and I'm going to take away my y1 value. So what I'm doing is I'm using this whole measurement here, and I'm taking away this part of it right there. That's what this equation is doing right here. Okay, and so if we come back to our equation now up here, that is our y distance here, which was 4 in our case here, which was 4 in our case right here. So we're looking at 4 squared, so I need, in here I need y2 minus y1 squared. Okay, and this is going to equal my distance. Okay, so this is going to equal distance now. But do we have just distance here? When we figured out the calculation, we didn't have just distance here. We had distance squared. Okay, so when I got down and I figured it out, I had to square root distance and square root the rest of it. So here, what I'm going to do is, rather than figuring out the calculation first, I just want d by itself. So I would have, normally I'd have a square up here, but instead of putting the square here, I'm going to put my square root over here on all of that. Okay, and that allows me to get rid of my square root then. So I have d, the distance, equals all of that. Does that make sense, I hope? Okay, if you guys have any questions, please feel free to email me, write me, find me some way, give me a call on my phone, whatever you need to do. Okay, use the process you came up with in number 4 to find the distance between 2 points located far enough away from each other that using your formula from number 4 is more efficient than graphing and counting. For example, find the distance. So let's find this distance right here. So -11, 25, and 23, -16. So do I even need to plot these? Do I even need to put these on a graph? I don't need to put these on a graph. Okay, they're going to be really far away from each other. this one from x2 to x1 is going to be, what is that, 20, 33, 34 points away, 34 units away. So those are really far away from each other. So what we're looking at here is going to be, for example, find the distance. So we're going to be using our x's and y's. So negative 11 is x1. Okay, and this is x, let me make this a little clearer. X1 and y1. And then we'll use x2 and y2. Okay, so I have negative, we're going to go x2 first. So 23, okay, minus x1 is negative 11. Okay, so I put it in parentheses so I don't lose track of my negatives. And that stays squared. And that is plus, okay, my other distance, which is going to be y1, or y2, sorry, negative 16, okay, minus, again, y1, which is 25, and that is also squared, okay, and that is going to equal, oh, I forgot my square root out here, that is going to equal my distance between those 2 points. So if we look at this, I've got 23 minus negative 11. So let's do that calculation first. So 23 plus 11 is 33, and that's still squared, plus negative 16 minus 25. So negative minus a positive gives me a bigger negative. So I'm going to have a negative, and then 5 and 6 is 11, 2 is 41. And that is also, so because there's a negative here, I need the parentheses to say that negative is included in the square. Okay, that has to be included. You have to have the parentheses around that square because otherwise that negative is not included in the square. Okay, so now we jump to our calculator here because I don't know 33 squared. Okay, that gives me 1089 plus, so negative 41 negative squared gives me a positive number because the negative is inside. Okay, 1681. Okay, and this all equals our distance. So our total distance is going to be 1089. No, 1089 plus 1681, and that is going to be, so D equals, and oh, look at me, I'm just losing stuff all over the place. Forgot my square roots. So D is going to equal the square root of 2770. Okay, which according to my calculator is an ugly number. So D is approximately 52.63 units. Okay, so for this, if you get an ugly number like that, leave it like this. I would much rather have an exact answer than a decimal approximation here, guys. Okay, so make sure that you are using your calculator, double check your answers, double check your work. A lot of big numbers here that you're dealing with. Okay, so use your process to find the perimeter of the hexagon pattern shown in number 3. So if we go back here to number 3, okay, this hexagon right here. So let's clean it up so we can see what we're doing again. Okay, so we need to find the hexagon pattern around the circumference of it, around the outside here. So all the way, come on, give me a color I want. There we go. All the way around the outside right here. So I need to find all of these. Do I need to find every single one of them? Nope, I sure don't. Okay, because this one is going to be the same as this one, and this one, and this one. And then this guy is going to be the same as this guy. So if I know what BC is, which we do, I can take 4 times that. BC, we said, was equal to 4.12, or the square root of 17, right here. Okay, we can take 4 times BC is going to equal all 4 of those sides, is going to equal 4 times the square root of 17. Okay, and then I just need to find this distance right here. Well, lucky for me, I have a right triangle here. Okay, or actually, sorry, we're supposed to do it this way. So we have B is here. So it was supposed to be out here at 4. Okay, so B is out here at 4. A is at -4. Okay, I don't have a grid on this one, so I'm going back to my grid here that I know is correct. Okay, so we're at -4, -4, comma, +4. That's my X and Y value for that. And then here we are at, let's grab a different color here. Let's go purple. Here we are at, whoa, that is yellow. We're at 4, comma, 4. Okay, so those are my 2 points. This is A, and this is B. So here, let's go back to the question here. So we had one of them. So A was at -4, 4, and B was at 4, 4. Whoa, my pen stopped writing there for a second. Okay, so if we use our formula here, we have the square root of, let's label all these again. So I have x1, y1, x2, y2. These are supposed to be 2s, sorry. I don't think my pen knows when I'm writing sometimes. So we're going to use, what was our equation? Where'd it go? There it is. So we're going to use the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to find our distance that way. So we have x2 is 4 minus -4 squared. Come on. Squared. That's a 2. Plus y, ooh, not y. Y has a value. So y2, 4 minus 4 squared also. Okay. That's going to give me 4 minus 4 is, I have 4 minus 4 is 8 squared, plus, or 4 minus -4, sorry, gives me a 4 plus 4, gives me 8 squared, plus 4 minus 4 is 0 squared equals distance. Is that 0 okay? What does that 0 actually mean? If we have a 0 there, what happened? Well, the 0 is showing that from here over to here, there was no change in our y value. So we didn't go up or down at all at A, and we didn't go up or down at all at B here. So that's why we have a 0 for our y difference. Okay, that's why we have a 0 right here for our y. So I end up with 8 squared plus 0 squared. 8 is 64, plus 0 goes away, equals our distance. Oh, no, it doesn't. The square root of that, there we go. Square root of that equals our distance. So our distance there is going to be 8. So that's our distance for that long segment. Okay, then we have the distance for these short guys is the square root of 17. So if we come back here, I've got 2 times that distance and 4 times, call that distance 1, and 4 times distance 2 is 4 square root of 17. Okay, so when we add all those together, that's 2 times 8, not 28. So we get 2 times 8 plus 4 times 17 square root. Okay, I get 16 plus 4 times square root of 17 is 16.49 or 32.49 is our circumference. Approximately our circumference. Okay, so just to make this a little easier to read, 32.49 is approximately our circumference. Okay, so hopefully if you guys remember what we went over before, you shouldn't have any problem with the RSG. It'll be a good point, a good practice for you. Some of the stuff that we talked about. So this is all the same thing we just did today. And then this guy right here, same thing. I don't see anything you should need help on. If you need help, I am always available. Please reach out to me. If you have any questions, I am happy to help. And I hope to see you guys soon. I hope everybody's staying safe, staying inside. And I'll talk to you guys when I talk to you. Have a good day.